All right, guys, today we're going to talk about how to show that lines are perpendicular. So we have a couple of theorems. Remember, theorems are statements that we could prove. We're not going to prove them. We're just going to use them. But we could prove them if that was something we were inclined to do. So the first one here says that when two lines intersect to form a linear pair, so remember, a linear pair just means that they form a straight line, they're adjacent angles, they share a vertex. So we're looking here at this situation. So we have two angles that form a linear pair of congruent angles, meaning that angle 1 and 2 have to be the same, then those lines are perpendicular. So in reality, we're not looking at this picture. This isn't the right picture. What we're looking at here is that we have a straight line and that those two angles are formed, making congruent perpendicular lines. There we go. So congruent angles, perpendicular lines. There's the first one. So if you know that we have a linear pair that's congruent, then they're perpendicular. All right, on to the next one. So if two lines are perpendicular, then they intersect to form four right angles. So what that says is that if we know we have this picture right here, we have this picture, then we can say that all four angles are perpendicular. All four angles are right angles, right? So that one makes sense, pretty straightforward here. So if one of those angles is 90 degrees, all of them are. All right, let's keep moving forward. If two sides of two adjacent acute angles are perpendicular, then the acute angles are complementary. So that's just a pretty complex way of saying that if you take a situation where you have perpendicular lines and they have an angle, so we have two adjacent acute angles and they form a perfect right angle, then they're complementary, all right? So here's angle 1, here's angle 2. Angle 1 plus angle 2 equals 90 degrees. So if we know that the two adjacent angles are perpendicular, then the angles are complementary. Add together to equal 90. I think this is all making sense. All right, let's keep going. So let's use one of the theorems that we just had. We said that if we know that one of these angles is 90, then all of these angles are 90. So we could do this. And so how we solve this problem is basically just saying that, hey, I have 2x plus 12. That has to equal 90. So we go 2x equals 78. Or x equals 39. But wait, you might say, hey, Bradley, can't you do that a different way? And I would say, yes, of course you could do that a different way. You could take this as a linear pair, right? Combine those together, go 2x plus 12 plus 90 equals 180. Subtract 90 from both sides, we get 2x plus 12 equals 90. And then look at that, we're back at the same problem we were just doing. So no problems there. More than one way to do a problem, and that's okay. All right, let's keep moving forward. Here we go. Here, they're asking us, find all of the angle measures that we can. So we're going to do a little bit of work here. The first piece of this might be to look for where are 90-degree angles. So let's highlight that. There's a 90 right here. We also know that this is 90, so that gives us a lot of information. Well, 2 is 90. That was given to us. We also know then that all of the rest of these angles that meet on this intersection right here are going to be 90. So that means angle 3 is also 90. And it doesn't help us much with 4 and 5 because those are two angles, and 1 and 30 are two angles. So we'll have to think a little harder about what to do with that. So if we know this right here is 90 degrees, then 1 and 30 are complementary. So if this is 90, then this would have to be 60. So angle 1 is 60 degrees. Okay? And so with that same thought in mind, we also know that this angle right here is 90, right? We know that's 90 because we were told that right here. It said this was 90. So if that's 90, and we know that this part is 30, then 5 is also 60. So 5 is 60 degrees because the two of them were complementary. They had to add together to equal a right angle. And then the final piece here is that we know that these two angles here are 90. And if those two angles are 90, and we know this part is 60, then this part has to be 30. So angle 4 is 30 degrees. Okay? So, again, these complex problems, it's just taking them piece by piece and looking at what you know, what can you figure out, and how can you use that information to be able to break this apart. This comes with experience. You will get faster at it. All right. A little bit more information to share with you guys. So, if we have a transversal, remember transversal crosses two lines in the same plane. If a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other. So what this says is if we know this, then we know that both lines are going to be perpendicular. Okay? If we know that one of them is perpendicular, then we know that they both are. This applies if they are both parallel lines. So we have parallel lines cut by a transversal. One of them is perpendicular, then the other one has to be. Okay? That wouldn't be too hard to prove, but we're going to just use it and keep going. All right. Now the reverse of this. So if in a plane we have two lines that are perpendicular to the same line, then they are parallel to each other. Okay? So we can come in here and we're saying that if we know that they are perpendicular, then we know they are parallel. So what we could say would be like the corresponding angles are congruent, then the lines are parallel, right? So that makes sense. So this is just an extension of that idea. We would call it a corollary, but that doesn't matter. So it's an extension of the idea that if we know that corresponding angles are congruent, then the lines are parallel. If the lines happen to be 90 degrees, then they are both congruent, and therefore those lines have to be parallel. Okay? So that's it for our conversation of perpendicular lines today. Hopefully you'll be able to use some of this in class. Good luck.